Do you guys have my laptop feed? I think maybe. Yes. There we go. Okay. So B-side, as Isabel said, has sort of a few-year history of working with TouchDesigner pretty heavily. Initially in themed entertainment, escape rooms, sort of touring experiential things like that, and that kind of randomly led us into applying those same kinds of techniques to the automotive space. And so I'm going to cover the sort of suite of TouchDesigner-based software that we've built and I'm going to sort of speed through a little bit the software itself and then try to get to some techniques that are like applicable to other work that people are doing in TouchDesigner. So we started building this suite of software about 2 years ago for a company that's building an autonomous ride-sharing service. And they had all of these sort of hypotheses about how people and self-driving cars were going to interact in space. So what it means for a robot to make eye contact at an intersection, how you get a drunk person out of your robotic taxi when there's no human driver to do that, like all sorts of issues. And their teams of designers and psychologists and everyone like that had a bunch of sort of thoughts, but they didn't really have tools to figure out if these hypotheses were true. As most people know, self-driving cars are still somewhat nascent developmentally. And so they were a couple years away from having spent the billions of dollars it costs to actually sort of answer these questions fully in the real world. And so they recognized that a lot of the kind of work that gets done with TouchDesigner by companies like ours in terms of melding screens and sound and control of physical devices in the real world responsively and sort of non-linearly was perhaps applicable to their work. And that this would maybe be a sort of much faster way to try to build sort of essentially theatrical environments that we could test a lot of these theories with actual people and allow designers to kind of see what things were going to look like in a few years once they actually got these vehicles fully built. And sort of this final half of that was they wanted the ability to sort of take what designers were creating in the tool we developed in TouchDesigner for them and actually export that data directly to the vehicle pipeline because programmers are really expensive, and using really skilled AI developers to like type keyframes into files to control, lighting sequences and stuff is really inefficient, especially if all that data already exists in a tool that the designers have created. And so we developed this tool based on similar pieces of TouchDesigner development we'd done in themed entertainment for them, sort of collaboratively with their design team. And so sort of the key things were, this is a tool that is not meant for TouchDesigner users to use. It's a tool that's meant for UI UX designers and automotive designers, industrial designers to use themselves to sort of rapidly iterate on ideas and say, like, what happens if I change this response, or what happens if I change what this lighting fixture does, or what shows up on this screen in response to sort of these conditions. And so we drew pretty heavily on some of the user interface elements of TouchDesigner, of other tools like Isadora or Quartz Composer, sort of other nodal environments, pulled ideas from After Effects, pulled ideas from a lot of 3D environments, Photoshop, and tried to kind of smush them all together into a tool that was intuitive for non-programmers to use. The other sort of half of that is it's an authoring tool that needs to control a lot of different hardware, and what that hardware was kind of evolved over time, and it often required sort of more computing horsepower or outputs than we were going to be able to get on one computer. And so we had to sort of tackle a challenge that I think TouchDesigner people come across a lot, which is how do you split up your project across a bunch of computers, and how do you sync them together appropriately? How do you deal with that load balancing? And we had sort of the added challenge, which was that we didn't entirely know what the designers were going to create with this tool. And so we needed to develop sort of a distribution system that was able to evolve and adapt to changing hardware requirements and changing use cases without having us sort of go behind the scenes and recode things too much. So this is sort of the system architecture that it has. There's what we call the author, which is a software running TouchDesigner that I'll show you. And this is sort of the GUI. This is where you use nodes and timelines and inspectors to sort of create your design. And that produces a big JSON file that sort of defines all of these behaviors. And that is then split up across sort of any number of engines, which are like headless processes, also built in Touch, running on one or more computers, potentially the same as the author, or potentially sort of several other computers. And each of those engines then sort of takes on a subset of the overall output and processing duties. There's also a wireless remote running on a tablet, so they can, during user testing, trigger things, and using a UI on the remote that also they can customize within the author. And then finally, that all takes inputs from sort of standard stuff like contact closures, non-standard stuff, sort of like CAN bus, automotive components, and outputs as well, to a mixture of NeoPixel-y DMX fixture type stuff, as well as automation controls for motorized doors and seat belts and all these kinds of things. And this is, I'm just going to leave this up for 1 second. People can kind of look at this later, but this is just sort of all the different protocols that these different pipes can talk. Cars are full of like a lot of different communication protocols, and that's particularly true in a prototyping environment where we started off with components that were sort of heavily theatrical, so we'd make little light fixtures that kind of loosely resembled what the designers thought some of these components were going to look like. And then over the course of this collaboration, we would swap those fixtures out for actual production prototypes coming from the real automotive suppliers. And those generally have very different electrical and communication needs, and so we kind of add and subtract and change communication protocols. But the key thing is all of that kind of under the hood stuff is abstracted away into the design environment, so a UI UX designer doesn't really have to think about whether they're outputting to a headlight that we made out of parts from Adafruit or a headlight that is actually automotive grade and controlled completely differently. So I'm going to show sort of a quick example function that is not at all what you would build in a car, but sort of a quick way to look at how you would build some behaviors in this tool. So we have a seatbelt, which is sort of a binary input, right? It's buckled or it's not buckled. And when it's buckled, a task light, like an overhead light, comes on with a fade. There's also kind of like a NeoPixel ring type fixture that will rotate and change color. And then finally, we'll add the ability to do the same thing from a button that we create on the tablet. So this is kind of what we call the graph view in Xperience. And so it's pretty straightforward. You have nodes. Nodes really do, while they look kind of similar to TouchDesigner, functionally they're a little bit different in that with TouchDesigner, we were talking about this yesterday with Ben. In TouchDesigner, we're moving whole data structures through the wires. This is more like a tool like Isadora or Quartz Composer, where you're moving triggers or numbers or text, sort of single variables almost through each wire. And each of these nodes has these sort of little inspector windows you'll see in these screenshots, and I'll show you the real thing running TouchDesigner in a minute, where you can sort of edit various parameters. So basically, we create a seatbelt. We can decide what the inputs are. We can drop in sort of fade nodes that are just timed value changes. We can wire those to the intensity input on output. And again, like the user of the software doesn't really have to think about how that seatbelt is wired. They don't have to think about that task light. They can just say, like, I want that thing to do this. And behind the scenes, the software kind of takes care of all of that. And this is all obviously totally real time. We can create a timeline, or what we call composition node. This is where you can sequence video, you can sequence audio, you can create keyframe tracks of values with various interpolation types or colors. And then we can create a gradient. This is kind of a Photoshop style gradient tool. Obviously, we have linear, we have circular, again, different interpolation types. And the idea was these would all be really familiar to people who are used to sort of Adobe design tools or sort of any other common design environment. We can also sort of expose the parameters of those and drive those off of the timeline, so we can animate parts of the gradient by wiring them up like that. And finally, we connect it to a light fixture. And so this is like really simple example. In a real automotive environment, obviously each graph would have a whole lot more functionality. And if you, on screen, you can see there's this graph manager. So you can have any number of graphs at any given time running that are all communicating with each other. So you can sort of split this up however the designers want to split it up and turn on and off chunks of functionality to test. Finally, we can sort of go over to a little tablet view. Again, we have sort of any number of panels, which are layouts of buttons. The tablet functionality is pretty simplistic because it's really just about like creating triggers and indicators for primarily user testing or investor demos, things like that. But we can create a button, we can change the color, we can change the label, we can expose a channel name for it. So we have a sort of OSC-ish communication protocol that basically allows us to say when this button is pushed, it's going to broadcast on a channel that we call test. And then back in the graph, we can create a button in Node that is looking for that channel called test. And again, how all of that is dealt with behind the scenes, they don't really have to think about any of that. So that's kind of the loose overview. Under the hood, what that's all getting turned into is this JSON. Obviously, there's a very tiny chunk of the JSON that would form that whole graph. But we chose JSON for a couple of reasons. One, obviously, it's really easy to parse. Python loves it. It is very human readable for us. So as we were developing, it's really easy to troubleshoot. Like when we have an issue, is it that the author kicked out crappy, garbled JSON, or is it somewhere in the engines it's not getting parsed properly? And we chose this whole sort of syntax and how we laid out our code very early on in the process, and we're pleased to find that it really did not ever become a problem, which is always nice when you make a technological decision early on in a sort of long-term open-ended development. And so this is sort of a simple, in bold, you can see it's the same JSON, but we've changed now the fade time from 1 to 2. And so it's really easy to see what's going on in the JSON. It's also nice because it can be easily manipulated and diffed and stuff in Git. So one of the key requirements with this automotive client, really any automotive client, is there's a lot of intellectual property considerations working with them. And so all of the sort of business logic or sort of what they're creating with this tool needs to be externalized from the tool itself so that they can manage it on their own, locked up flash keys and whatever. So by using this JSON, those JSON, all of the sort of graphs and behaviors and what their animations look like and what their behaviors are, that all lives off in their own data stores, and they can just sort of bring it into the software, manipulate it, it goes back out into the JSON. So one of the techniques we developed fairly early on is this thing we call domain filtration. So we initially built it so that basically there was a couple engines. One handled sort of basically all the lights. One handled essentially like all the video. And that we hit scalability issues with that really quickly, as one might imagine. And so we developed this thing which basically starts with any of the nodes that are considered an output node, so are associated with a given target output piece of hardware. So in this case, the task light. And we say which engine is responsible, physically connected to that actual task light. And then a sort of recursive function that Dave from our team, who's in the audience, wrote that basically sort of recursively works its way up the chain of the JSON and throws away all of the parts of the graph that are not relevant to that specific output node. And it does that for all the outputs assigned to a given engine, thereby sort of whittling down the whole graph to only the portions of the graph that are required for that particular instance of the engine. And this was great because A, it lets us distribute across computers. It also lets us run multiple engines on the same computer, thereby multi-threading our process. So we generally would have 2 or 3 engines sort of per physical computer. So in this case, it would start with our task light. It would figure out, of course, that the fade up and fade downs are required, and also that the seatbelt is required. But that means it doesn't need to instantiate the test button or the warning pulse or the gradient or the LED ring or any of those nodes on the engine that's responsible for this task light. And this scales really well. It does create other issues, which I can talk about a little bit later, in terms of synchronization. So we ultimately solved those with the sort of synchronization framework that will lock multiple composition nodes or sort of any other time-based node across these different engines. We'll lock them together. Not quite frame accurate, but pretty much frame accurate. It's not genlock. But that sort of solved that issue. And so you can see here again in the JSON, it's going to look for this device that's called task northwest. and then that engine knows, okay, on my list of devices I'm responsible for, Task Northwest is there. And so I'm going to sort of figure out what else I need. So one of the things I want to talk about is sort of some of the GUI techniques we used on this that are maybe informative to other people. So one of the big things is sort of an adapted version of what's called model view controller architecture. This is fortunately a term that's starting, I find, to like come up in TouchDesigner conversations because it's a really powerful software development technique. And so essentially the big thing is, and I will now switch over, if I exit, I can show you guys in the actual thing. It doesn't run that great on Mac, I'm warning you. Not TouchDesigner in general, but this particular thing we developed has not really been QA'd for OS X particularly. So, but if we look at, this is the author, it's really split up into sort of two sections of toxes. On the stage right side, so screen left side, there's this sort of long list of libraries, command line parser, managers, generators. So these are all essentially dealing with the business logic of the software. So these are dealing with parsing JSON, with sending data off to the engines, with filtering things, managing undo. So there's like full undo redo functionality that we implemented. So like all these things that you are expect in any other software, we had to kind of rebuild all of that. And so that then all gets passed over to the various parts of the GUI itself. And so if I jump in here, back into perform mode, we can see down here in the very bottom, there's this command line. So in theory, for troubleshooting purposes or whatever, you can actually type out commands that are like, digital in, change value to seatbelt 2 or whatever it is. But in reality, it's a good sort of visualization of what's going on with this model view controller. So if I go into my circular gradient, for example, and I change this handle to be red, what you can see down there is there's this command that gets created, set value node circular gradient to color, and then this color. And so basically what's happening is this inspector window that we've created has no actual access to the JSON itself. What it's doing is it's basically just sending back a command to the sort of central manager of the graph's data, which is then parsing that into the JSON. And it's doing that with potentially some other sort of filters. So it's looking at how that particular change perhaps impacts other nodes in the graph. Which in this case it wouldn't, but if we're making connections or things like that, there's perhaps some sort of additional error checking or things like that that need to happen. And rather than doing that in the GUI side of things, we're doing that in sort of this business logic side of things. Likewise, when I look at the graph here, all that's actually been created is sort of the JSON that's only the part of the JSON that's required to show me this information has actually been parsed. So if I look at this composition node, all that actually is a rectangle with sort of inputs and outputs. It doesn't have any of the actual sort of composition data living in that. That's all sort of safely off in the JSON because at this point in the process, my GUI doesn't care about that. But then when I click into it and create and the inspector gets created, that chunk of the JSON is basically being queried from the central JSON repository, and it's being passed over to the module that has just been created to show us this inspector. And sort of back and forth like so. So that's kind of loosely this model view controller idea. It's really good for a couple reasons. One is it makes it really easy for us to make GUI changes without really impacting anything else. It also makes it really clear where all of the sort of logic lives. So it makes troubleshooting on a project of this sort of scale and sprawlingness as easy as it's possible, I think, to be for something like this. Makes it really easy to literally look because it's giving us these readouts in the bottom. Users can see, hey, I'm seeing weird stuff down there. Can you guys look at X? It also means, from a performance perspective, if I have a really sprawling graph, TouchDesigner on the author side isn't having to deal with data or GUI elements or really anything that it doesn't need to deal with exactly at that moment. And so I can create, I can create multiple inspectors, so I can it'll scale to instantiate sort of whatever functionality that I need as a user, but it's only showing me sort of exactly what I need at any given moment. Likewise, if I had a whole bunch of graphs here, that doesn't actually create any additional workload for the author application, because those graphs only exist as JSON files as far as the author is concerned until I open one, and then it basically replicators out all of the functionality, renders the wires, etc. And it does that pretty responsively, which is great. One sec, let's see. Oh yeah, so the inspector pop-ups are a good one that I'll just quickly show sort of how we do those under the hood, because they're, I think, pretty handy. So we do a lot of stuff, if I jump into GUI graphs, where we kind of have a library of externalized elements, and then the view controller can basically request that one of those elements gets replicated, gets given a unique name that can be referenced for data purposes, so the node's name or the element, the touchscreen element's name or whatever, and then data can sort of get passed back and forth to it. So if I go into Inspector Windows and jump into, or if I go to, let's see. Where is my library? Sorry, it's been a little while since I actually worked on this project. Oh, I forgot. I helpfully moved these elsewhere in our project for Git purposes. So if I go into, not UIlib, into complib, there we go. So we have a library of a lot of sort of externalized elements that get used then throughout the rest of the project to make it easy to sort of keep track of what's been externalized, what needs to be saved, and then do our best to manage it all with a sort of coherent Git workflow. But if I go into Node Inspector Library, we can essentially see these unpopulated node inspectors for almost every kind of node has an inspector. Some there's no options, but pretty much everyone has inspectors, and that's all different kinds of things. A lot of them are just like checkboxes and numbers and stuff. And obviously these, for handiness sake, are actually constructed out of a whole different set of sort of GUI element toxes that we've created that create drop-down menus and color pickers and stuff based on TouchDesigner's native elements that do that. We built all of this before widgets existed, but based on that, but sort of in some cases customized more specifically for our UI needs. And so when I double click on a node, essentially what's happening is that node element in our graphs, so if I go into active graphs, we can see all the nodes that currently exist on the graph. So by double clicking on one of those, that's getting passed all the way up to the model view controller, a request is getting made, it's sent back down, the inspector, it's getting added to this list of sort of open inspectors, which is triggering the script that has some sort of error. And then it's actually getting created and populated with the JSON it needs to have. And this, scales really well. And it's, I think, a pretty easy technique to replicate on other kinds of projects where you need to sort of have a library of modules that you create. Other things. Yeah, I'll just sort of show. So the node graph is being created really with a pretty similar technique. If we jump in here, one thing that I'll sort of point out is we use a mixture of, generally speaking, we lean pretty heavily on panels for building as much of the GUI as possible. For primarily performance reasons, ease of use reasons. There's a few things like the wires that connect the nodes that I'll show in a second that we do in 3D space with render picking, because that was just sort of a lot more efficient and easy to do that. And obviously what's great about TouchDesigner is we can really intermingle those techniques pretty fluidly. So to the user, it's not obvious that the wires are being built with a completely different technique than the nodes that they're connected to. And so if we jump into a composition, we can see, obviously there's a whole lot going on here, but one thing that maybe is clear-ish, but is like, obviously none of the actual, that whole composition, like I said earlier, that doesn't actually exist in here. It's just whatever's required to create this node. And so it's kind of just like taking the JSON and whittling it down to send to the different parts of the node that we need. And each of these, we build all the objects in a way that I sort of think of as like slightly self-aware. So like the port on the node sort of knows just enough about itself to be able to make a request that says like, hey, I've been clicked. And then it sort of passes that up the chain, and the model view controller will say like, okay, if that port has been clicked and this other port was just clicked, that probably means they want to wire between those two ports. And then it'll add that to the JSON and send it back down the chain. The other thing is all of this, anything that sort of exists in the data. So if we click on the panel layout, rather, we can see that like the X and Y position, reflects where it is, obviously. That also is mirrored in the JSON. So at any given time, there's no saving. Everything is sort of constantly being updated to the JSON, with one exception, which is the actual position of these nodes. So when we first built it, everything was constantly updated to the JSON, and that ultimately sort of produced some limitations for us when we started implementing some slightly more sophisticated behavior, like, for example, click to select multiple nodes and then drag them all as a group. That got really hard to do and or very non-performant. And so we ultimately sort of broke our everything lives in the JSON at all times rule in this one instance. And so now if we do like a group select, we can drag them all as a group. And that does not propagate to the engines because the position of the nodes on the graph does not impact the actual sort of business logic execution of the system. And so the engines don't really need to know every time you move a node, and it's not really good for performance to have to tell them. And so if we look up in the corner, it now sort of gives me a warning that says this graph contains unsaved changes. The only changes those could possibly be are the node positions. All other changes are always saved. And if I switch graphs, it'll automatically save that. If I quit, it'll automatically save it. So it's short of a crash, which occasionally happens, you are never really going to lose those changes. But that's sort of one area where we kind of had to break that rule. Because what's happening is like when I click and drag, all of the other nodes that are getting dragged are very quickly being populated with expressions that point to the position of the node I'm dragging. And then as soon as I'm done, that kind of all gets restored back to how it should be. So there's a few places where we're kind of like stretching our internal rules about how we build this. But for the most part, kind of everything's mirrored in those two places. Oh yeah, and then I'll show the wires because those are kind of fun. So if we jump back into our graph, wires are a really good example of render picking. Here, actually, I'll show them in use first. So one thing is obviously like we have a few things that the wires do. They show connections, obviously. If I click on a node, they show what the connections are, what that node is connected to. This was a fun sort of user request. So one of the interesting things is a lot of the projects we've worked on are things like retail and things like that, where you don't get user requests, right? You build the thing, and then it goes out into the world, and it lives for months or however long. But with our client, they have actual full-time employees who their full-time job is to use Xperience to prototype things. And so we get feature requests from them saying, hey, it'd be really great if whatever. This was one when a new designer came on board, and they had huge sort of tangle rat's nesty graphs that had been created by previous Xperience users at the client organization. And they were saying, it's really hard to follow where any of these wires go, which is a pretty valid concern. So this feature was added at their request. The other thing is, if we're going to erase, we're using, interesting. Like I said, this is not super happy on Mac. In theory, and this is normally how it would work, if I mouse over that wire, it would turn red and just show me that I'm deleting the correct thing. We have we have not optimized this well for DPI scaling because it's only meant to run on the computers we've deployed with them, which all have the same monitors. And so we've done a not very good job of making it work happily on other computers. But this is a really good sort of textbook render picking application. And so again, if we go to GUI graphs and we jump over into our active graph, so there's a bunch of kind of like slightly janky, but ultimately pretty robust stuff that's happening behind the scenes, and essentially all of those connections are getting populated in real time from the nodes themselves. And the reason we did it that way is because the wires need to know where the node ports are, and those node port positions are based on where the nodes themselves are, and the nodes themselves are not always correct in the JSON for this sort of previously mentioned caching reason. So we are using kind of a lot of like evaluate DATs and things like that, producing all these positions, and then it's all getting sent to our wires, which are basically sort of extruded along an S-curve from the right position to the right position, and then our render pickable, and that's kind of just in the background. And this has worked super well. Once we got through some sort of early optimization stuff on our end, that worked great. There's now actually that wireframe material didn't quite work for us originally, but would now be totally perfect for this, and so for optimization reasons. And again, it's pretty standard. We can see there's kind of all the wires are just getting rendered out and then pushed back into the main panel. And this works. I didn't show it, but like you can zoom in and out on a graph and you can pan it around and stuff. So if you have really big sprawling graphs, and again, this is one of the things where the panels in TouchDesigner work really great because it saves us as developers from having to really think about any of the how do we deal with mouse coordinates, how do we deal with any of that stuff. It just kind of works, which is lovely. Yeah, so this is Xperience. We can do questions now, if anyone has any questions.
Questions. Okay. Okay. Thank you, Matthew.
Yes.
Hey, I just have a question. Why did you choose to use TouchDesigner in place of using like a Qt or normal GUI framework that we use?
Yeah. So there's two main reasons. One is we have a lot of experience with TouchDesigner, so to some degree, like you use the tool you know. The other thing is originally the sort of first version of this software, which looks probably 90% of the way to what I'm showing now. It implements, timelines, all these gradient stuff, all the graphs, everything like that. We built that in like 5 weeks, including sort of a whole a UI UX design process with the client. Simultaneously, we were building a lot of the hardware for this. So and that was with a team of like 2 of us really. And so I don't think any of these other tools would have allowed us to build something quite this sophisticated in that amount of time. The other thing is TouchDesigner is really great for talking to hardware. And so by sticking within the TouchDesigner family, when they said, hey, can we add OSC communications to a web app that we're using to prototype touchscreen implementation, it's like, sure, give us an hour, And so that's been TouchDesigner's proved to be a really strong choice on this because it's allowed us to add a lot of functionality over the course of this collaboration very quickly, like really, really quickly. It's also much easier to troubleshoot than if we'd built all of this using tools that are a little less visual. In certain cases, a lot of the visual pipeline stuff you can build really quickly. So it's really a lot of the sort of the shortcuttiness, right? TouchDesigner is doing a lot of that work for us. And on a project like this, like obviously the cost of the licenses is not really a significant factor. And in terms of distribution, like we're not trying to sell this software really. It was built for a specific client. We've since adapted it, but any clients that we're deploying it with, it's a very sort of high-touch model, and so TouchDesigner is really good for that.
Amazing. Greg, I can tell you have questions.
You only have about 100 questions,
Yeah.
but I'll keep it to 3 or 4. Yeah. So, I mean, it's astounding that you're building a node-based tool based on top of another node-based tool that suits a different purpose. So I think that's terrific. Like, just on a higher level, what kind of conclusions or insights do your clients get from using a tool like this? I mean, what's their...
Yeah, so it's been, we're a little limited still in what we can talk about with the clients who've used this, but there's been a huge amount for them. So they had, the main client this has been used with had a lot of theories about sort of how sounds would, and the combination of sounds and lights on the external surfaces of a vehicle would communicate with people, and what people would think certain things meant. And most of those were wrong. But they were able to find that a year and a half, 2 years before they would have if they had waited for the vehicle to test with, which in the automotive space is like a savings of like millions and millions of dollars. So there's been really substantial like business advantages for them, and it also allows them to iterate really quickly. So they can say, that didn't work. What if we tweak it like this? Let's try that. So, and this was a little bit surprising to me when I started working in automotive, but if anyone owns a car and knows how bad like the infotainment system in it is, you'll sort of understand this is like the process by which an update on a vehicle to even the simplest thing gets made, even in the prototyping process, is like very, very protracted. So basically the process would be like a designer would say, hey, I want that light to fade up in 2 seconds instead of 1 second. And so that would sort of go into like a design request, which goes to like engineering review, and that gets turned into like an engineering change order, which goes to Germany in a different time zone to some supplier, who then like processes a lot of paperwork, and then it goes through like a multi-committee process of getting signed off on to make sure it's not going to break any like safety rules. And then it goes back to the engineering supplier, who then puts it on like, who then like loads the firmware, maybe on a flash key, or maybe you have to send back a whole part of the vehicle to Germany for them to firmware flash it, and then it like goes back to San Francisco where our client is, and then they can put it in the car, and then they can look at it and be like, nope, we wanted a second and a half actually, and then like 4 months go by. So, with this, right, they can just really quickly do that, and they can see it like in the actual vehicle environment, which is, I think, something that people who design in like theater or stage environments sort of take for granted, and is like pretty mind-blowing when you're working in like transportation and automotive.
Yeah, it's amazing how you're swapping out simulated output devices, like a little thing on a screen, for the real hardware at some point, and just experimenting with things that way.
Yeah, and in fact, actually, this client has multiple test setups that they use for different purposes, all running the same software, and some of them have some combination of production and non-production components. Some of them have totally different combinations of prototype and non-production and production components, and they can take their JSON files and flash key them back and forth between their racks and use them without having to really think about that at all. It all just kind of gets dealt with. And again, TouchDesigner is really good for building that kind of functionality.
Okay, and one question that I can ask here, because it's our festival.
Yeah.
What node types are you most dependent upon in TouchDesigner these days?
Yeah, so we use a lot of the timer chop. That one gets used a lot. There's a lot of eval DATs. I'm a big fan of the eval DAT. There were a lot of TD in and out DATs that were dealing with communication. We've slowly replaced those with some of like some separate multi-threaded communication protocols that Dave has developed separately to deal with some of our needs. But those are pretty big ones. Yeah, so I mean, there's a lot of communication. There's a lot of data going between the engines. So and it's actually bidirectional. So the engines, there's a probe tool where you can sort of mouse over ports and see what's flowing through the pipes in these completely separate engines.
It also has a sound feature. You can actually, yeah.
Yeah, right. So there's sound, there's video, there's screens that are getting output too. So there's a lot of data moving around. We're using a lot of NDI for previewing purposes back in the author. I don't know, Dave, am I missing anything? Extensions. There's a lot of extensions, yeah. Yes, there's a lot of just comps with extensions. There's, I mean, probably hundreds of thousands of lines of Python throughout this thing if you add it all up, because it's very heavy on the Python front.
Do you find sometimes you have to re-engineer things because your data blows up too much, or your number of your nodes blows up too much, so you have to rethink how you engineer it? Or
yeah, so I mean, there's certain things like, for example, when we first built this, we used the replicator a lot, and the replicator has some scalability issues when you start trying to do like a lot of replicants, and ultimately, Dave, basically, we have our own version of the replicator now that we redeveloped entirely separately using script DATs and things like that execute DATs that met our sort of scalability needs a little better.
Yeah, we recently put in a feature, I think it's in 30,000, where you don't actually ever delete replicants. You just kind of leave them as a pool, and you just kind of shrink it down. But it stays there and occupies the memory so they can get used later.
Oh, interesting.
So it's like a reuse, kind of a pool. But
cool, yeah. Yeah, and we still use there are still some replicators. Like the ports are getting replicated because there's not that many of them. But yeah.
Do you guys have any questions? Okay.
Yeah.
So I know that you said you built it primarily for users who were coming from previous design environments. Have you found that that is typically the user base that's using it, or have you also had people coming from more of like a coding background or so, and how have they found interacting with the node-based environment?
Yeah, it's been pretty much entirely people coming from a design background. There's been some people who have some sort of web front-end experience. I would say that's the closest. Like one of the main users at our client has like some JavaScript experience, stuff like that. And I think it's interesting because like in certain cases, I think it's a node-based environment can be a little frustrating early on if you have no experience with it and only experience typing things to code. And I think certainly in his case, there was a little bit of a learning curve. Designers, node-based environments are really common in 3D authoring tools for things like texturing and stuff like that. And so the industrial designers, people who are coming from sort of doing the VR prototyping work, those kinds of people really took to it. But even for the gentleman who had a little more of a developer background, it really was not that steep of a learning curve. I think we tried to make it really intuitive. And I think sort of in general, once you wrap your head around what the vocabulary of a node-based tool is, if you're reasonably tech savvy, it's not that hard to latch onto.
We still have a few minutes. All right.
Hi, it's not really a question, just if you can show like some real demos of using this.
Yeah, so one thing just to point out is there's no engines attached to it. You can see all those zeros up there. So one thing is the engine doesn't run on OS X for various reasons. Not that we couldn't make it, but we have never sort of done the testing we need to do that. But so, I mean, if we jump into the circular gradient, I sort of briefly showed this, right? But we can change the color around. If I wanted to, for example, control the color of this node parametrically, I can click that, and then when I X out, we'll see there's this additional handle number 2 color port added. If I go over into the composition, which you'll see is a little twitchy on Macs, but and zoom in, I can, for example, let me drag this guy out of the way, and collapse these so we have a little more space. I can create a new data track, which is going to be hidden under this one. And I can go ahead and add a color channel to that. And then I can create a couple keyframes. And I'll get my color picker. Yeah, this is a Mac bug. Oh, there we go. Yeah, it just takes a second to update on OS X. So if we wanted to have like that over the 90 frames that this composition is, we have that. Or if we want it to be shorter, we can just grab our handle and shrink that track, and then drag it to wherever we want it in there. I would show you the image functionality. Unfortunately, the way it works is all the files for the screens actually live on the engine computers, and there's a process that basically creates all the keyframes and sends them back over the network for the author to use. But because I'm not connected to any engines, I can't create a video track because I have no files that it sees. But so we can do that. So I mean, that's kind of the simple thing. If we wanted to add like an additional fixture, let's see, those are all down here. So if we wanted that to go to a second pixel ring, for example, we can just go in there, choose that. We can wire those up, like so. So yeah, I don't know if there's anything specifically you want me to show. I'm happy to, but like I said, it's a little. I'm a little handcuffed in terms of what it'll actually do because it doesn't have any engines.
What other softwares were in the automotive space when you started this process, and were you able to draw any inspiration from them, or were you basically just recreating their workflow? And follow up to that is, have you seen any copycats or similar workflows coming from this software?
Yeah, so the automotive space was pretty early on the VR bandwagon for pre-visualization purposes. So tools like Blender and other sort of authoring tools, Unity, sort of game engine, Unreal, things like that, those are really, really common. And most automotive design labs will have sort of a dedicated VR person or team of VR people that are creating sort of prototypes, allowing designers to see things. Obviously, anyone who's used VR knows it's not really quite the same as like actually interacting with something in physical space. But it can be a really good complement. And so we tried to reflect some of the UI elements that like a Blender user or a user of those tools might be familiar with. In terms of even certain little things, just like the way the nodes are color-coded doesn't quite match, but the idea of sort of color-coding different types of nodes, things like that, are pulling from those tools. The other thing is like obviously like basically every industry uses Adobe Creative Suite, so trying to reflect some of the elements of things like After Effects, some of the things like Photoshop, just trying to make sure those feel those are sort of familiar vocabularies for those people, because they'll have motion graphics artists, and they'll have people who use Photoshop for renderings and things like that. We've not yet seen copycats, mostly because only recently were we even allowed to start like showing screenshots of this. This is sort of like one of the first times that this is getting seen in the world, and so I think it's probably too early for that to happen. I think the other thing is like this kind of tool is a niche within a niche within a niche, and so it requires a certain mindset in the automotive space about how they want to do their prototyping process. And so we've talked to, I think it was sort of fortuitous that and not coincidental ultimately, like the first company that we worked with on this is doing autonomous mobility, is building their own vehicles, but specifically for a rideshare application. And they were really trying to do it in a very design-forward way. And so they were already trying to kind of like push against some of the ways that a lot of automotive companies normally work. Like most automotive companies, you'll never have the designers and the engineers in the same building. The design studio is a separate part of the campus, often a completely different campus entirely. This company puts them all in the same building. Like those little things are actually like pretty big steps in automotive. And so this was a tool that really was well suited. And I think people in our community have an approach to making work that was really well suited to this particular client. There are other clients out there that we've talked to, other bigger automotive companies that have, they're younger designers who are like, that would be amazing. And I think there's still some like adjustment period across the industry for people to be like, it's not enough to produce, an infotainment software that looks like it's from 2015 in our 2020 model year. And it's not the designer's fault, like it's the process's fault. And so I think this can be and hopefully will be a really good tool for some other companies to start adjusting their process, but it does require an adjustment to your process. It's not enough to just like write us a big check and have us drop off some computers, And so I think that's the process. It's probably a multi-year thing. And we've shown this at CES with some automotive clients. We've met with a lot of people, and there's definitely interest, but it's going to take a while for the mindset change to happen. And obviously the design process that's happening now is for cars that are coming out, years from now. So it takes a long time for this to happen. I know I'm out of time.
Brilliant.
Yes.
Thank you so much, Matthew. That was
good.
Amazing.